So, hello everyone, welcome back. This was the question given from a subscriber. He says that considering an isotropic linear non-conducting non-magnetic and inhomogeneous dielectric medium, D is given by this. Show that wave equation is this, and we need to write down the scalar equation for Ex from the above equation and interpret physically that what happens when situation. So, from in let me just talk about the third part first. It says that from inhomogeneous to homogeneous. So these are the equation of in homogeneous. These are the homogeneous equations where jf and rho f are zero. I hope you can current density and charge density are zero. It means that no charge and no current is present. It means the medium is homogeneous. So you can see that nothing is there in the right hand side. Or from the mathematical point of view, we can say that what are homogeneous equation whose right hand side is equal to zero, and inhomogeneous whose are not equal to zero. So you can relate. I hope you can understand that del dot E is equal to rho bound by epsilon naught. So row free, sorry, not bound, row free by epsilon naught. So this can be considered as inhomogeneous part. Similarly, the del cross B term, here comes the current density part. This is the charge density part, that's the current density part for inhomogeneous part, inhomogeneous condition. So now considering our question, what we need to prove is the wave equation, this wave equation. I think there is a negative mistake. I found it down in the question. If you didn't find it, let me know in the comment section below. Let me help. Make me understand it. So what is D? D is epsilon E. It is given in the question, and epsilon is given by epsilon naught n square E. All right. So now taking the curl for this equation, if we take the curl, it becomes like this, and then applying the formula. The formula is del cross A. Suppose A is any vector, it becomes del into del A, where this is the dot product, minus del square A. Del square A means del dot del. This is del square. All right. First from the vector, then from the del itself. Now we just applied the formula in the left hand side, and from the equation, from this equation we got the here. But they are our question, in our question it is given that the medium is non-conducting. I hope you can read that this is non-conducting. So if it is non-conducting, then jf, the current density, will be zero. Simple. No current is present. How the density can be there? So on solving for the del, let me choose another pen. Yeah, del del E minus del square E minus del square E by del t square mu naught epsilon naught. Simple. And now the important thing comes here. I just take the all the comes to the towards the left hand side and taken zero here. So the trick is that del dot E I have changed. How? Because D is epsilon E, it is given to us. And what is del dot what is sorry what is E from here? D by epsilon. And taking the differential del both sides, uh, divergence both sides, we get del square E minus del 1 upon epsilon from here, and del epsilon from here only. All right. This is the change from here to here. Minus del square E by del t square mu naught epsilon. It is also simple. Del square E minus, now again look carefully, what is epsilon given? Epsilon is epsilon naught n square, which depends on all the this is here. All right, n square. So epsilon is epsilon naught n square del. And what is D? I just solved. D is this epsilon naught n square E. So as n depends on x, y, z, all the three components, and del is also the differentiation in with respect to del. I hope you know that what is del. It is x I j I cap plus y with respect to all three. I hope you read in your mathematical physics course. So just putting the terms and then cutting the epsilon, because it does not depend. So finally we get del square E minus del 1 upon n square del n square dot E minus mu naught epsilon del square E by del t square. So this is the wave equation. Now what he's saying, he's saying that write down the scalar equation of Ex from the above equation. What simple, what will you do? Ex, simply just applying Ex, and remember n also depends on x, so you need to be very careful while solving for 1 upon n square del, because it has all the three. You can, what you can consider is nx I cap, ny j cap, and nz k cap, sorry k cap. And then as it is, then you can calculate n square. This will it will not n square is simply when you'll do square, or the magnitude will come only, not the direction. So it is very simple to do. Now considering this, it has n square and e, simply the dot product. When you will take the magnitude and take the dot product, it will be very easy for you to solve, and then applying the divergence. So it is just the mathematical physics course that you studied in your first semester of graduation, not that hard. But the main thing is, the main point of this question was to, if it has asked in 2013, I guess. So the main thing was to put the del dot d here, from this to this. If you directly put del dot E is equal to rho by epsilon, rho f by epsilon naught, and then find out the things, it will not make it for you, because it will be a little hard in calculation. You'll find out later. So the trick is here only, that you need to solve from here to here, and just apply the Maxwell equation, and it will be easier for you to solve. I suggest you to read book of Griffiths only, and one book is also there for this unit. For these concepts, I'll recommend you in the description. Either I'll give the link, or give you the name. I read it in my graduation times. So that's all for this video. See you in next video. Bye bye. Take care.